Hello, I'm Zachary Beyer. I'm a high school student in Michigan with a passion for astronomy. If you fly through space, you will not see what astronomers lead you to expect. Interstellar space looks completely different from famous images released by NASA or other space agencies. To begin, astronomers do not use normal cameras. They use a charge-coupled device, otherwise known as a CCD. A CCD measures the amount of light that enters a pixel, converts that into a numerical value, inputs that into a data table, and then converts that data table into a black and white image. You may be wondering why astronomers just don't use normal color cameras. This is due to the pixel size. The pixel in the color camera has to collect red, green, and blue light compared to a CCD just collecting white, which allows for a smaller pixel and a greater pixel density than a color camera. A greater pixel density allows for more detail. Black and white images are preferred for astronomical photography. This is a black and white image of a gas cloud in active star forming region. This image was taken through a filter that isolates light emitted by hydrogen. The second issue of astronomical photography is the lack of light. Many objects do not have a nearby star bright enough to provide light for photography. To solve this, astronomers allow the shutter of the camera to remain open for long periods of time or for multiple exposures. Some images can take days to even weeks to create. For context, most cameras allow the shutter to remain open for up to 1 second. Even after this exposure time, some images still need to be brightened using an editing software. Astronomers still use color images, but not in ways you expect. A property of chemical elements is absorption and emission of light by electrons to increase or decrease orbit and energy level. Each element absorbs and emits a different wavelength of light, allowing astronomers to identify elements present in an interstellar object by looking for absorption and emission lines in the object spectra, all light invisible and visible that is emitted by the object. This is called spectroscopy. This is the visible part of the sun's spectra, the light emitted by the sun. The black bars represent light that is absorbed by elements, showing a presence of different elements in the sun's atmosphere. Filters can be used to only allow the emission wavelength of a certain element to contact the CCD. This shows the location of that element. This is done multiple times for different elements to find the location. These images are then assigned a color value and overlaid to create a color image of the object. This is how a majority of images of space are created and what is released by space agencies. This is an image of the famous Pillars of Creation in the M16 Eagle Nebula. Blue in this image represents oxygen, red represents sulfur, green represents both hydrogen and nitrogen. The colors show the location of the different elements in the nebula. The presence of dense amounts of gas, like in this image, allows star formation to occur. The elements present impact the properties of the stars formed. This is a color image of the gas cloud shown in the first image. This is after 3 images were assigned a color value and overlaid to create a color image. This is how many images of interstellar space are created. This is just the beginning of the differences of space photography. CCDs are only useful for visible light, some ultraviolet, and some infrared light. This is only a small part of the electromagnetic spectrum. Wavelengths of light that are invisible to the human eye still provide useful information to astronomers. Astronomers use different instruments to photograph this light. These images then are assigned color values to create a false color image of light that is invisible to the human eye. These can be overlaid with images from CCDs to provide more detail and information about interstellar objects. This is an infrared image of the Pillars of Creation with longer wavelengths than visible light. Infrared images provide more information, which allows astronomers to see through the gas and to see the stars that are formed on top and inside the pillars. Images of interstellar objects are created to serve a purpose and provide information about element location within the object, but are not created to provide an accurate representation of the appearance of the object.